Така че сега даваме думата на Мариан, за да ни покаже как се бекъпват хиляди от контейнери.
Мерси. Не само за контейнери, т.е. тази бекъп инфраструктура може да я ползвате за каквото си пожелаете в общи линии, стига да използвате LVM. Това е основното нещо, за което е свързано с тази система. Кой съм аз, за хората, които не ме познават, защото виждам доста познати лица, но има хора, които... Sorry, it's an English-speaking talk, sorry. Why I started in Bulgarian, I don't remember. So... And I was the one insisting that it should be in English. Sorry. So, who am I? For the guys who don't know me, my name is Marian. I'm Chief Head of System Operations of SiteGround, CEO of 1H, CTO of Kyup, and for the past years, I have been helping OpenFest, except this one, because I had a child a month ago, so I didn't have enough time to help OpenFest this year. So why am I qualified to talk to you about backups? My first backup system was built in 1999. Then there wasn't any actual suitable, working open source backup solution at that point. And I had to back up like 40 machines in an office every day, have them ready if one machine dies to recover it as soon as possible. Since then, I have built or helped architect 10 different backup systems. You would ask, why would I need to build a custom backup system when there are softwares like Amanda, Bakua, and stuff like this? Simply because of scale. Every time you have to scale to 1,000 machines or more, these systems are not particularly suitable for these workloads. And there are issues all the time with these systems that you cannot easily overcome. So then you decide to build it yourself. I decided to give this talk because I'm very proud for the last 2 backup systems that we built. And one is for our container infrastructure. We back up, I think, 2,000 or 3,000 containers already with it. It was built to have a lot more. And it was very satisfying to see that it works better than expected. So I will be talking about container backups, and also at the end I will be telling you how you can restore a machine within 10 minutes, 2 terabytes of data within 10 minutes. So first of all, backup considerations. Usually when you build a backup system or design for backup system, first of all, you think about storage. And the storage is the capacity of this storage and how reliable it is. Usually, you don't have one copy of your backup. You usually do a lot more copies. So this tends to grow in storage. And then you decide, OK, we'll do incremental backups. These things tend to break sometime. And after you have decided how you would structure your storage, how many copies you have, you decide on the speed of your backup, but you think of speed like the speed of your hard drives, the speed of your write arrays. Usually, nobody thinks about the network with these backups. You simply have backup, so it's not a problem. But depending on your infrastructure, maybe you can say, OK, we'll have a network interface dedicated only for the backups and restores. But nobody thinks how many machines you actually have on this network. So here are some stats that this is SSH speed, rsync speed on 1 gigabit network, 24 megabytes. This is the normal speed that you get from the normal write arrays that you have. I'm talking about commodity. I'm not talking about something server grade. I know that on 1 gigabit you can reach like 80 megabytes, but both your host server from which you backup and the backup server have to be able to maintain the speed. So average is around 24 megabytes per second. If you have 10 gig network, you get around 110 megabytes per second. And I know that theoretically you have to have a lot more, but practically, these are practical speeds. This is something that I measure in our network, on our network infrastructure with rsync, with standard SSH. And what this tells you is that you have to wait around 21 hours to recover 80% of your 2 terabyte drive. And most of us now have machines with more than 2 terabytes of data, like 6 or 8 by 2 terabytes. And this amounts to a lot of time to recover this data. If you have 10 gig network, you can have a lot better experience with 4 hours and a half for recovery, but the problem still remains, will you have the backup machine with so fast hard drives? Will you have a hard drive that can actually write with 110 megabytes per second? If you don't use SSDs, 110 megabytes are impossible for you. So this is a problem that you have to think about when you're designing, because it's not only backupping the data, it's also restoring from that data how much time you would wait. Everyone who has lost a hard drive knows how long it takes to recover this data from a backup, if you have one. So usually with the network, the other problem is that on one switch, for your private network, for your backup network, on one switch you have multiple machines. What if multiple machines die on this switch, and you have to recover from the same, on the same switch, 2 or more machines? Usually, these switches, if we are talking about 1 gigabit network, for example, here in Bulgaria, you get uplink 1 gigabit from the switch, but you have like 48 1 gigabit ports within that switch. So you have 48 machines on 1 gigabit uplink and only 1 gigabit to the next switch. And if your backup server is not on the same switch, you're fucked. So usually people have to think about uplinks of these switches. Even if you have 10 gigs on the uplink, what if from these 48 machines, 11 break? And you have to recover 11 of them. Again, you have overlapping problems with the networking. And also, the backups are okay, but if you have backups and restores working all the time, like you have to back up these machines today because you need at least 1 backup per day. But also, a customer decided to request a restore. And it's not the only customer on this switch that requested restore. They tend to stack up, and this takes your network. So either your backups are slow or your restores are slow. You have to design your system in a way that you can control both ways, so you can think about the network and the capacity that you actually have. So the containers infrastructure backup that we built was designed to handle 100,000 containers. The idea was that we can scale it to so many machines without any change of the infrastructure. So we had to back up every container at least once a day, but every customer can decide how often actually he can back up his machine. So if he decides he wants a backup every hour, we start backing up his container every hour. The issue here is that we had to design it in such a way that if it is theoretically impossible and practically impossible to back up this container, the data from this container within 1 hour, we have to increase we have to decrease the amount of time that we'll start a backup for this user. Instead of 1 backup every hour, we would create 1 backup every 2 hours because it's impossible to copy the data 1 hour. Also, our system was designed in a way to keep 30 incremental backups. It was important for us to have at least 30 days of data. So if a customer comes and says, okay, 2 weeks ago, I deleted one file. Can you please help me? I have the money, I don't have the data. We will have the data and we'll get the money. I'll explain how you can do this. First, we use LVM. I wasn't a very big fan of LVM till 5 years ago because I lost quite a few logical volumes on my machine. But we started using LVM for a few use cases in our company. And for this backup, LVM was the perfect solution. Why? Because it has snapshots. What is a snapshot? When you have your data, you have one partition with your data. In certain point in time, you simply stop this data, get the view of this data, and everything new is collected on the site. So you continue to have your data changing all the time, like, for example, having a MySQL database, and it changes all the time on the disk. But you have a snapshot, which is a picture of your data stored in time, stopped in time, that you can access every time. And these snapshots, you can copy whenever you want. Also, the setup on the host machine was one RAID array. I would not tell you what type of array or how many disks, but on the host machine we have a single RAID array that exposes a single drive, and on this single drive we are creating a single physical volume. On this physical volume we create a single volume group. The issue here is that in this volume group we create a tin pool. What is a tin pool? LVM allows you to have tin provisioning, which means that you can create a logical volume that the customer will see as like 60 gigabytes or 100 gigabytes, but actually it will take 1 megabyte of data. Until you start filling this volume, it takes only the amount of space that's required for the metadata for this logical volume. So when you add like 600 megabytes of data to this logical volume, it's not 60 gigabytes, it's 600 megabytes. And it grows only when you add data. This is very nice because it allows you to add more volumes than you actually have space for. You can overcommit your storage, and when you see that the storage is running out, you can actually move a logical volume from one machine to another machine and free up some space. So tin provisioning, very important and a very big pain in the ass for us. I'll tell you more about this later. So for each container, we have a single logical volume. If you have another setup, like for each of your machines in the office, you have a single logical volume, it's the same situation. You can have this setup again. So on the backup nodes, again, we are using LVM. Again, for snapshots. So what's happening here is we keep the snapshots here for the incremental backups, and I'll tell you a little bit more in a bit. Again, we have a single RAID array exposing a single drive, but instead of a single physical volume, here, currently we have created 5 different partitions, and in each partition we have created a single physical volume. Why? I'll tell you when we reach the issues. So on each of the physical volumes, we have created a volume group, again, tin provisioned. Why tin provisioned? Because, again, even on the backup servers, you don't want to lose space for which is not used by your clients. This is space wasted. So when we create a new backup, we actually create a snapshot of the current logical volume, and we keep 30 logical volume snapshots for each client. When we create the 31st, we simply delete the first. That's it. It's a very simple incremental backup. Till now, so for the people that have done backups, remote backups, everything should be straightforward. You should know these things. So let's start with the fun part. First, we use rsync. Most of you most probably use rsync for backups. The problem with rsync is that we had a few issues related to our containers. First, we want to know how much files, how much size data was removed from the backup. Why is this important? Because we cannot calculate this from our commands like df and du. You cannot see the actual size of this backup. Because of incremental backups, does everyone know what incremental backup means? So everyone else doesn't know. Okay, I need to explain this. Very important part. Normal backups, when you copy the data from one machine to another machine, you have all your data here on the other machine. When you decide to create another copy, you create another directory and copy again the data. But most of the files in these two directories should be the same. They haven't changed. If they haven't changed, they have to be the same files. So actually, you lose space by copying a lot of times the same data. So incremental backups are a very simple solution of this problem. The first time you create a backup to the machine, you create the full copy of your data. And the second time you create a backup, instead of copying all the data again, first on the backup server, you copy this data here. Sorry, you don't copy it. You create links, hard links, from your data here. You create hard links here. Another directory which is hard linked to here. And what this means is that you have created inodes, but you didn't lose any space from your machine. And on these files here, you now rsync, and only the changed files are replaced on this site, on this next directory. So incremental means that you have added only the changes to your backup. There are other solutions, like this was done with rsync and hard links. With LVM, you actually don't need to create hard links and so on. You simply create snapshot, and only the changes are added to the next volume, and so on. You get different snapshots with only the changes. You don't copy the data, the data that you already have there. This is very nice because allows you to save a lot of space from your machine. So the problem is that when you're using LVM in such situations, you actually don't know how much data was removed, deleted files. And why is this important? Because based on this data, based on these statistics, you must clean up the logical volumes. Why? Because when you remove files from your snapshots, they don't release the space on your host machine. They release the space in this snapshot, in this logical volume, but your hard drives still have all the data. So Valentin here, over there, can you stand up, please? This is the guy who actually implemented this in our infrastructure, this whole backup. So he found out that we don't release the data, and he took 2 weeks to actually find why. And spoke with LVM maintainers to see what we can do. And I have added to the slides the command that you need to issue after you unmount, very important, unmount your volume. You have to bulk discard your partition. So all the data that is released from your volume is returned to your volume group. Discard the data that was used. Since this operation takes some time, we don't want to execute it every time after a backup. So we base this decision on the amount of files that were, amount of data that was removed. And we patched our sync. Our patches are online. You can get them there. The branch deleted stats have the deleted stats information. The second thing that we also had to patch was when we're storing files to a client's container, usually we have to SSH to the client's container and our sync files directly there. But since we have containers on this machine and they share the same kernel and so on, we decided that we'll be more ingenious and instead our sync directly changes his mount namespace to the mount namespace of the container and can put all the files inside the container without SSHing to this container. This is extremely nice for our restore system. Again, mount and S branch, you can see what we have done there. Maybe it's a little bit rough, but it works. So the backup system architecture, what we have done. Created a centralized database on one container that has the information for public and private IP addresses of each machine. For each machine, and I mean backup server and host machine from which we are copying the data, we have defined one very important metric, which is the number of slots, the number of backups or restores that can run simultaneously on this machine. This number, we manually have reached the number for our machines. For your machines, it would be something different. So it depends on the speed of your hard drives, on the speed of your network. This number allows us to define the maximum that we will use this machine for. And with this limit, we can be sure that we will not hog this machine. And we collect also, I'm sorry, no, I don't have it here on the slides. We also have information for which private IP is in which data center or rack. So this way, we can also know how many data will be copied from one backup server or two backup servers, how many data is going through each switch. We are using standard top-of-the-rack networking, so one switch per one rack and one switch for the whole array, for the whole row. So it's very easy to calculate if the racks are on the same row. This means that they're going through only top-of-the-rack switches. But if the machines are between different rows, this means that we are not also going through the top-of-the-rack switches, but end-of-the-row switch also. So we can take into account the number of backups running over the switches based on the number on the slots that we have used. We are using Gearman for messaging layer, but this you can replace it with RabbitMQ, Zookeeper, or whatever messaging you want. The idea is that instead of actually running parts of new daemons infrastructure that have to have logic and everything on each machine, we have created workers for this. And we have on the centralized machine one daemon that actually controls everything, starts the backups and monitors if a backup has took more than 24 hours to finish or more than the amount specified by the client. Then the backup workers that are installed on each backup server. So the scheduler is a pretty simple thing. It checks if the container has to have a backup first. Then checks the last timestamp of the backup. This is important for us because we create each logical volume on the backup server with a timestamp. So the timestamp is important for us because it's the name of the logical volume. Why we need that? We need the last snapshot from which we have to create a new copy before we start syncing to it. So this is why we need the timestamp of the last backup server. We also use this for accounting purposes to see the time, how much time each backup is taking. So after that, the scheduler checks if we have enough slots on the backup server and on the host machine. on both machines, if we have enough free slots, at least one, to start the backup, and schedule a backup. The backup is scheduled directly through Gearman on the backup machine. So nothing is done on the host machine. The host machine analyzes a database, and we have an API on the host machine that we write to when the backup is finished from the backup server. The start backup worker is relatively simple also. On each backup server, we start a worker, which is a normal script for us. We write in Perl, so it's a Perl program that we start on each machine. If you have like 5 slots for this machine, we'll start 5 workers on this machine. This means that each time we add a job to Gearman on this local machine, it will go directly to the first worker. If we add 10 jobs to this server, this means that 5 are directly executed, started to backup, and 5 are waiting in the queue in Gearman to see if, to wait until one of the workers is finished with the work and it will get the job, the first job after that. If you want to get more slots on this machine, you simply have to start another worker, and that's it. It's pretty simple. The start backup worker actually creates the snapshots on the backup server, prepares everything. Then SSHs to the remote machine, to the host machine from which it will backup everything, prepares everything there, snapshot, then starts the rsync and monitors the rsync process. If the rsync dies for some reason, collects the data from the crash of rsync and reports back to the centralized system to say there was a problem or the backup has finished. After the backup has finished, it has the job to remove the snapshots that are, if we have reached the maximum number of incremental backups. And finally, updates the database, the centralized data. Till now, everything was fine, but we started using this system, and maybe the first or second week after that, we hit a very, very big bug in LVM, and we actually lost, I think, 2,000 backups, 2,000 containers, their backup. We lost 2 nodes. The problem was corrupted volume group, and it's not the data in the volume group, only the metadata for the stupid volume group was corrupted. And this is why I really hated LVM 5 years ago, because there were no tools to recover this data. There are still no tools to recover this data. There are ways to prevent the metadata breakage. First lessons that we learned is volume groups need more space than we actually give them. So if you have a 2 terabyte volume, physical volume, you shouldn't create a 2 terabyte volume group. You should create like 1.9 terabytes volume group and leave some space to extend this volume group when your metadata is full, or not when, before your metadata is full. Because when it is full, you're fucked. Yeah, we were fucked a lot of times from LVM. So the first issue that we hit was we create a lot of snapshots. And when we told the LVM maintainers that we maintain 2,000 volumes within a single volume group, they said that it is not supposed to work. It works, kinda, until those 2 nodes died. Oops. Yeah. So what happened was we created a lot of volumes. We exhausted the metadata, and when we rebooted the machine, the LVM was unable to actually analyze all the data, all the volumes that it actually had, and we were unable to mount any of the volumes that we had. Whatever we did, we had to recreate the backups from scratch. So you have to create your volume groups a little bit smaller than your actual physical volume size. Also, there was an issue with the physical volume metadata. So your physical volume has metadata, your volume group has metadata, your logical volume also has metadata. Every time any of those metadata is full, you know it. So in order to minimize the crashes, if something breaks again, we didn't want to lose all of our backups, so we decided to split the volume groups to 5 on each backup node. This is why we have 5. For you, it may be 2, it may be 4, it may be 10. It depends on the risks you want to take. So we decided to split it to 5, so next time, at least it would be a little bit less data that we have to copy. The other problems started to mount when we started to use the restore system. First of all, every time you create a logical volume or decide to mount a logical volume, LVM decides to check on all device files that you have in the dev folder. And since we have 2,000 snapshots, we have a lot of devices there. So it takes a lot of time to actually mount the stupid volume. Or create the stupid volume. You can remove this problem by first changing obtain device list from UDEV to 1, enable it. Then you actually ask UDEV to get you the device number for your logical volume, and you don't give a shit for every other device that you have. The second problem is that usually LVM creates a cache for this data, so it doesn't need to browse all the files in the dev folder. Unfortunately, it's actually faster to browse the files instead of browsing the cache for 2,000 containers, so for 2,000 snapshots. So we decided to stop the cache. It doesn't work. If you don't have a lot of devices, maybe the solution that they offer you to use the scan directive in the file would be enough. In this directive, you need to add all the volumes that you want to monitor, and this is it. But this means that every time you create a volume, you have to update this list, and you have to reload the daemons. The other problems were the metadata daemons. Since we have this metadata for the volume groups, for the logical volumes, and so on, there are daemons to cache some of the metadata information before it is written to disk. Caching this information, maybe it's a good idea for performance, but not writing this information to your hard drives when your machine breaks, panics, and so on, is a very big problem because infrastructure. I think I lost the sound. No. It's not the battery. It's not mute. Okay. We found the sound. So, LV MetaD and DM MetaD. DM MetaD is responsible for your devices on your machine and the metadata for your volume groups. So when it breaks and it doesn't write the cache-changed metadata from the memory to your hard drive, you lose your volume group. It's that simple. LV MetaD, it has the same properties, but it's related to the logical volumes themselves. So what we found was that LV create leaks file descriptors to both of these daemons. And usually they're started with a very small amount of number for file descriptors, around 2,000, I think, or 4,000. Unfortunately, if you create a lot of snapshots and then remove them, you leave a lot of file descriptors in these daemons. So the first thing was to create a script that monitors if, for some reason, the AOV method daemon or DIMI method daemon is started with less than 65,000 file descriptors limit. We have to increase that. This is very important. If you run out of file descriptors, you cannot mount at all your volumes. Even if you have them, you cannot mount them. So these are the major issues that we had. There were a lot of smaller ones related to the scheduling of these backups. If you're interested, you can find me at the walk speaking table in the workshops room the whole day. And I can tell you a lot more about this. The other thing is our last backup system that we built. We named it Avatar. The idea was that each container, did I lose the audio again? Okay. So the idea was that each container is nice to backup as a whole, but it may take a lot of time if it is a big container. So we were thinking, why not, instead of backing up each of the containers, which are where most of the data is the same, instead we should back up the users of these containers inside. So since at SiteGround we are a shared hosting provider, we have a lot of users and we are using containers, instead of backing up the whole container, it would be faster to back up only users. And this means that if we back up each user on different backup machine, we can also restore from each backup machine to another physical machine. So instead of limiting ourselves to the speed of the drives on one backup server, we can actually utilize a lot more backup servers for the same restore of one machine. And we are also working on a solution where we can restore from multiple backup servers to multiple different shared hosting machines. When we do this, I'm told that it will be around 10-15 minutes to recover a machine with around 3 terabytes of data across the infrastructure that we have. So we can reduce this problem that is the networking or the hard drives limit by simply dispersing our data across a lot of machines. There are no other backup systems right now that allow you to have this dispersed backup data and to recover from that at all. We are thinking of open sourcing this next year. Simply the code is a mess right now for open sourcing it, but next year, maybe for next OpenFest, I will have another talk that is dedicated to Avatar. Each account now can be backed to another backup server, and if for some reason we can no longer backup it on this machine, for example, the space is, we have run out of space on this machine, we can continue backing up this account on another machine by simply creating one more copy of it, initial copy, and then moving the incremental backups here on the other machine. It's pretty ingenious. How does it work? The problem is that per users, if you have 2,000 containers on one backup server, think about if we have 100 users in each container. So LVM was impossible for this to have so many logical volumes. So we had to find a way to actually build a solution for this. So we still use LVM, but instead we create sparse files. These are empty files. And mount them through the whoop device. Then on this whoop device, we create a physical volume. On this physical volume, we create a volume group. In this volume group, we create a team pool. And in this team pool, we create the logical volumes and the snapshots for each user. It's, again, very nice solution. We have, for each user, a single file that is mounted. And after we finish with the backup, we unmount it so we can keep the mount the mount count under a certain limit. And the limit for the Linux kernel right now is around 20,000 mounts actively working on your machine. So here we had also another set of issues. Currently, we hit a bug in the kernel that is so strange that we cannot fix it for now, even with the LVM maintainers. Currently, the max uptime for the backup server is around 19 hours. So the backup system is so robust that allows you to have your backup servers dying all the time, continuously. And this is for months right now. I think 2 or 3 months we are hitting this bug. And the backup system is still working. We still have backups. We have tested all the kernels. 2.6, 2.4.3, nothing fixes this issue for now. The issue is related to the discarding of data. When we clean up the data from one of the logical volumes, it simply triggers a memory corruption error in the kernel and plot. Removing cold snapshots doesn't discard the data. We hit this bug. It was very strange for us. We remove a logical volume, and we didn't receive any free space from that. We removed another, and still we had the same used space. This is when Valentin took 2 weeks to fix this issue with the bulk discard command. Also, LVM is stupid. So when your demo event daemon reaches the limit of file descriptors, it silently unmounts your volumes underneath your feet. And it does this very nicely with the lazy mount option. So you never know that it actually did it. Never. You don't see this in any log or whatever. We had to S-trace the daemon to actually see that it has done that. It was very strange when you get the reports, this backup failed after like 30 minutes, or this backup failed after it started 5 minutes after that. We were thinking about networking issue, while obviously it wasn't that. Also, if you don't watch your metadata for the volume group, when you reach a certain amount of size of your volume group, logical volume, I'm sorry, the LVM daemon will try to extend the logical volume. And if it fails, it unmounts your volume silently. Very nice. For this, we actually did a very bad patch to LVM by simply commenting out this logic for now. Also, the tin pool. Tin pool metadata, if you reach more than 90% of your metadata, you may not create a logical volume, or you may corrupt the whole volume group. And after a reboot, you would not be able to mount your logical volumes. So you have to monitor your metadata for the tin pool, precisely for the tin pool, and if it reaches around 90%, extend it as soon as possible. If you cannot extend it, remove some data from there as soon as possible. Definitely create the tin pools more than the volume group so you can extend it. Again, the same thing for the, you have to have spare physical extents in the volume group so you can extend the tin pool. This guy, Kabi, is a very friendly guy on IRC that actually helped us resolve most of our LVM issues. We are very, 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 very thankful to this guy for all the help that he gave us. We simply asked, this is our problem, can anyone help us? And this guy replied, tried to find the problem with us. So, any questions?
BTRFS?
So we're currently using LVM, yes, and I was considering things like BTRFS or ZFS. Actually, Valentin now is checking ZFS. Why not BTRFS? First of all, team provisioning in LVM is considered experimental, but it's experimental since 5 years ago in the kernel, while BTRFS snapshots are in the kernel since this year, I think, or late last year. They're a lot more experimental. And a few days ago, Valentin was in Moscow at High Load Plus conference. Baidu are using BTRFS, and they don't recommend it. So if a large provider like Baidu doesn't want to rely on BTRFS, we'll stay away from it for some time. I really like BTRFS, the functionality and everything. I simply don't want to lose more data. It takes a lot of time to recover it, if nothing breaks. So we're considering ZFS, ZFS on Linux, not the Fuse ZFS driver. But maybe next year I'll talk more about this. Do we have time for another question?
Yeah, what about the performance with so many snapshots?
What?
With LVM?
Performance with?
Yeah. Do you have any issues with performance with so many snapshots?
Performance? No. Any issues at all.
Okay, thank you all. Give a round of applause for Marian.